Prove by mathematical induction that 5 to the power 2n minus 2 to the power 3n is divisible by 17 for all n which are positive integers. So we start as usual with the least possible value of n. It's 1 here, so we write for n is 1. Our expression 5 to the power 2n minus 2 to the power 3n becomes 5 to the power of 2 minus 2 to the power of 3, which is 17, and it's clear that it is divisible by 17, so we write is divisible by 17, so it's true for n is 1. The next step is as usual, we write assume true for n is key, and our expression becomes 5 to the power of 2k minus 2 to the power 3k, but how can we show that it is divisible by 17? It can be represented as 17 multiplied by some integer. For example, let it be m, and m is positive integer. And the next, we should consider n is k plus 1, so we write for n is k plus 1. Our expression becomes 5 to the power of 2 multiplied by k plus 1 minus 2 to the power 3 multiplied by k plus 1 is equal to. And this problem is quite typical for such type of problems on induction, on divisibility. The first question is how to use this information from assume, and finally how to show that it is divisible by 17. To show that it is divisible by 17, if you get a few terms and each is divisible by 17, so overall expression is divisible by 17. Or again, if you can represent as 17 multiplied by something which is integer, so it is divisible by 17. And as usual, for n is k plus 1, we split into part corresponding to n is k and some additional terms. Why? Because then we can use information from assume, and definitely here we can see that we can split it into 5 to the power of 2k and something else. And how to do that? It looks like 2 to the power 3 plus 5 is 2 to the power 3 multiplied by 2 to the power of 5, and here it's what? 5 to the power 2k plus 2, so it becomes 2 to the power of 2k multiplied by 5 to the power of 2 minus 2 to the power of 3k and multiplied by 2 cubed. And you can see we cannot substitute directly for all expression 5 to 2k minus 2 to 3k, but and what should we do? We can solve for 5 to 2k for this expression and then substitute into this expression. It's quite typical for such type of problems. And hence we can use this information from assume. So it becomes 5 to the power of 2k, or actually it's multiplied by 5 squared, so 5 squared is 25 multiplied by, and 5 to the power of 2k. From this it becomes what? 17m plus 2 to the power of 3k, and then minus 2 to the power 3k multiplied by 8. And expand this, so to get 25 times 17m plus 25 multiplied by 2 to the power 3k minus 8 multiplied by 2 to the power 3k, and we can see that we can add like terms or just factor out 2 to the power of 3k, and it becomes, I rewrite 17 in front, 17 times 25m plus, you can see that it becomes 25 minus 8, which is what? 17 times 2 to the power 3k. And you should write, since each term is divisible by 17, this expression is divisible by 17, or we can rewrite as 17 multiplied by, for example, c, where c is positive integer, and definitely is divisible by 17, so true for n is k plus 1. And conclusion: if true for n is k, true for n is k plus 1. Since true for n is 1, true, you can see that here n is positive integer, so true for any n is positive integer. And that's all for this problem.